The question, Maximal store, it's a medium-level dynamic programming question. It's asking us to find the maximum square that contains ones. So in example 1, it's either the green one or the red one. They both have an area of 4. So this is a dynamic programming question, and I'm going to try to solve this using a top-down approach. So like other dynamic programming questions, first I'm going to use the Python decorator cache for memorization, and def-dp is going to take in a row and column as well. First, let me explain my approach. So I'm going to go through all of these by row and column one by one and check to see the one to the right, the one bottom of it, and the one diagonal to see if these 3 are all ones. If they are all ones, it means our area can be expanded to 4. And then then we check the rest, like if it's a 3 times 3 square or it's a 4 times 4 square. And for those things, we have to check if everything within the boundary are all ones. And for dynamic programming, we don't want to do repeated calculations, so that's why we have the cache here for the memorization. So for example, if we're on this position 0, 0, we have to calculate these 3 to see if they're ones. And if we're on this position, then we have to calculate these 3, right? But for this one, this was already calculated as part of the first position, so this would be already in our cache. Let me write out the code so it could be more clear. First of all, for this, we should check if our matrix exists. If not matrix, then we just return an area of 0, and then we can define our row and column length. Row equals length of matrix, and column equals length of matrix 0. And then we're going to start writing our dynamic programming recursive function. So first, like any other recursion, we need to check for the base case. The base case would be if R and C are within boundaries. If they are not, then we would return 0. We wouldn't add anything to our maximum area, right? Or maximum sign. So I would check if R is bigger or equal to row, or C is bigger or equal to column, or in the case that it's a 0, we also don't want to add anything to our maximum size, so we would do, or if matrix R C equals 0. For these cases, we want to return 0. That would be our base case. And otherwise, it means it's within boundary, and also it's a 1, so we would just return 1. Plus, we want to check the surrounding 3 grid positions that they're all ones, right? So to check that, we can check if any of them is a 0, then it wouldn't make it a square, so we have to check the min of recursively calling the DP R. Let's say R plus 1, so it'll be this position with C, or DP R C plus 1, or DP R plus 1 C plus 1. So this would be this position, and then R plus 1 C plus 1 would be the down diagonal one here. So the min means if any of these are 0, it will automatically plus 0, so it wouldn't add to our maximum area, maximum side. So this will calculate its maximum side, and then we have to call this. We have to call this DP. We have to go through every position, so for calling it, we can first define a variable called max side as 0, and for I in range of row, for j in range of column, we would return the maximum of itself, max side, or dpij. Actually, no, we wouldn't return that, sorry. That was a dumb bit. So we would define max side to equal max of max side, or dpij, and then in the end we would, after we went through everything, by the way, by calling this dp, we avoid the repeated calculations. If it's already a previously calculated grid ij position, then I would just retrieve that from the cache. So we would return the max side times max side. This is the area. This is how I would solve this question. The time complexity for this would be m times n, the area of this grid. Space is the same, so of m times n because of the cache. So this is how I would solve it, and let me know if you have any questions. Thank you so much for watching.